Hello, Chemistry 11. This is Mr. Chan. And what we're going to do today is I'm just going to show you a video introducing you to chemical bonding. Okay, we've talked about chemical bonding back in grade 9, back in grade 10, but I wanted to just work on chemical bonding just a little bit more. We dive into it a little bit more detail than what you did back in grade 9 and 10. All right, so what I'm going to do right now is share the screen. Okay, and you should have this as part of your note package that I gave you. Okay, so when we talk about chemical bond, okay, what is a chemical bond? It occurs when there's a mutual attraction, oopsie, between an electron and proton of different atoms. Okay, so when we talked about periodic trends, we talked about the electrons and the protons of a single atom, but now what we're doing is we're talking about how they interact with each other. Now, because there's a mutual attraction, so what happens in a chemical bond? You have mutual attractive forces between the electrons of one atom and the proton of the other, but you also have a repulsion between the two nuclei and the two electron clouds. So there's a mutual attraction and repulsion going on, okay? So what happens is this. So there needs to be a balance between this mutual attraction and repulsion between two different atoms, okay? So what happens is this. If we read here on the side, it says the electrons are simultaneously attracted to two nuclei, okay? And what you have is you almost have like a tug of war. So what you have here, you could think of it, I'm going to say this is like, AKA, you could have relationships. So in a relationship, what you have is you have a mutual attraction to each other, but you also have some repulsion to each other. Now, you might say, well, what is repulsion? It would be things like, what are some of your partner's characteristics that you just don't like? You might say, oh, you don't like how they slurp their coffee, or you might not like their hairstyle or the way that they dress. But the attraction would be like, wow, you like that person's personality, they have good character, whatever. And so what there is that in a relationship, just like there's a balancing act between the attraction and the repulsion, you have that as well in a chemical bond. Now, if the attractive forces override the repulsive forces, then the bond stays together. But if the repulsive forces override the attractive force, then what you have is you have a separation. Just like in a relationship. In a relationship, if the attraction overrides things that bug you, you stay together. But if things bug you override the attractive force, you end up breaking up or divorce. Okay? Now, with the attractive and repulsive forces, the atoms don't just boom, come together. There needs to be a balancing act, okay? And the distance between the atoms depends on the balancing between the attraction and repulsion between the atoms. So if we were to look at a graph, what happens is here you have potential energy here along the y-axis, okay? And you have the distance on the x-axis. Now, what happens is that here, the atoms, too close. And if the atoms are too close, what happens is that there's lots of repulsion between the atoms, or sorry, between the electrons and the nucleus. Here, this is too far. When the atoms are too far, what happens is that they are unstable because they want to have a full 8 electrons in the outermost shell. And here, at this lowest energy, just right. And in this case, there's a good balance between the repulsions and the attraction between two atoms. Now, what I'm going to do is I'm going to stop sharing here. And oops, you just see my roof. And what I'm going to do is I'm going to share a different screen to show you what I mean. So let's share this Google screen. So what happens is this. You see the screen. So what you have is, if we were to play this, okay, if I pull this apart, notice the little atom up here. It goes, okay. So let's do a bigger one here. So let's do neon. Let me see if there's a bigger one. Neon, argon. Okay. So what happens is this. When it comes in too far, notice the energy. If it's too close, notice that energy. Okay. So what you have is you have a balance. Too far, too close. Too far, too close. Okay. So what you have is you have actually a balancing. The atoms are actually moving back and forth. Now, if we look at the forces here, okay, so I'm going to do it slowly. So as it comes in, I'm going to pause. Notice the arrows pointing together. That's the attractive force. But notice you have purple arrows here. Those are the repulsive forces. So what you want to do is you want to have a good balance between the attractive force and the repulsive force. Now, notice here, the repulsive forces get really big. Notice what happens to the energy versus the attractive force. Notice, why is the energy really high? Is because there's lots of repulsive forces and not enough attractive force. And so this is why it bounces back out. Okay, and what you get is a balancing of the attractive and repulsive force. Okay, so that's what's happening in a chemical bond, is that there's a balancing of the attractive and repulsive forces. Okay, so what I'm going to do is I'm going to stop sharing, and then I'm just going to go back to my screen here. Okay, now that simulation was based upon here. Okay, so if you want to try it out yourself, what you can do is type it in, okay, and then play around with it. Okay. Now, depending on the nuclear charge and the shielding effect of atoms, the sharing of the electrons is not always equal. Okay. Depending on the inequality of sharing or difference in electronegativity, the bond can be classified in 3 ways. Now, what is electronegativity? Electronegativity is the ability to attract a shared pair of electrons. Okay, now this can be found in your reading package on page 333. Okay, now if you look on page 333 in your reading package, okay, let's have it here, you're going to see this particular table. This is called the table of electronegativities. And the numbers on the top that you see is basically, you could think of it, just their ability to attract a shared pair of electrons. So the greater the number, the better they are at attracting a shared pair of electrons in a chemical bond. Now, notice what's happening is this. Notice the numbers I just circled. They seem to increase going from left to right, and they decrease going down. The question is why? Okay? Hopefully, when I ask you the question why, you can understand it has to do with something that you learned in the periodic table. It has to do with the number of protons, neutrons, and electrons. So going back to your notes, what's happening as you're going from left to right across the periodic table, and what's happening to the numbers of protons, protons, and electrons, and the electron shells as you're going down. Okay, so hopefully you're able to understand that pattern relating back to the periodic table. Okay, so if we have the periodic table here, remember I gave you some graphs. Okay, what's happening to the atomic radius? Why as you go from left to right and as you go down? What's happening to, was it ionization energy? Did I have that there? Okay, so if we were to look at the ionization energy, what's happening there and why? All right. Okay, so let's go back to bonding. Okay, so if we're going back to our bonding notes, so for nonpolar covalent, what you have is, let's see, you have perfect sharing of the electrons so that the electrons stay mostly in the middle of the bond. Okay? So in this case, the pair of electrons are simultaneously attracted to both. Okay? So in this case, both the chlorine nuclei are engaged in a tug of war. Okay? So you could think of it, what happens is the electrons are equally pulled. Okay? Now, an example would be like this. So let's say we had a boat. Okay? So let's say we have a boat, and these little happy faces represent electrons. So the boat is perfectly balanced. What you have is you have 3 people on either side. So this is, a boat is balanced. So here is balanced. This is like what we would call polar covalent. Okay. Now, oh, sorry, nonpolar covalent, not polar covalent. It is nonpolar covalent. All right. Now, polar covalent is electrons are still shared. Okay. But due to one of the atoms being stronger than the other, the electrons are found closer to one atom than the other. As a result, one atom seems to gain electrons and the other tends to lose electrons. the apparent gain or loss of electrons of a charge is called a partial charge, represented by partial positive or partial negative, and the bond is a dipole. So what you have here is AKA slight unequal sharing. Okay? Now, if we were to use the analogy of the boat, if we had our boat again, okay, still we have the 6 happy faces, okay? What we would have is we would have 2 on this side, and we would have 4 people on this side. Okay, so here is unbalanced. And the side that has more electrons, this will be what we call partial negative. This side will be partial positive. It's still neutral, but you have an imbalance in terms of one side gets more electrons than the other. Now, in this case, notice chlorine is partially negative. Why? Notice, and hydrogen is this partial positive. Why is that? Is because there's an imbalance of electrons. Now, how did I know to put the partial negative on chlorine and not on hydrogen? Because chlorine has a larger electronegativity. So whichever side has a larger electronegativity will get the partial negative charge, okay? Now, because this is imbalanced, okay, because imbalanced, the bond is said to have a dipole. Dipole means di means 2, poles means 2 ends. So just like a magnet, okay? So this has a dipole. Here, because in this case it's perfectly balanced, there is no partial negative, partial positive charge. Therefore, it is there is no dipole. Okay. All right. The last one, ionic bonding, is not much sharing. Okay. It seems like one atom takes the electron for itself. Okay. So for ionic bonds, there's not much sharing. Okay. Now, so in this case, how would it look like if we were to use the boat? If we were to use the boat analogy here, okay, if this was the center balance, all 6 people would be found on one side. Okay? Okay? And in this case, this would be positive, this would be negative. Okay? There is no sharing. Okay? Oh, not no shadow. I would say, be truthful, very little sharing. Okay? That would be an ionic bond. Okay, so basically you're talking about the amount of sharing of electrons. Polar covalent, or sorry, non-polar covalent is perfectly balanced. Polar covalent means that there is slightly unequal sharing, and ionic bond is not much sharing at all. Okay, complete transfer. Okay, now to predict the type of bonding existing between atoms, one takes a look at the difference in electronegativity. This can be found on page 334. Oopsie. Page 334. So if you take a look on page 334 of your reading, you will see this particular chart. And so what happens is, depending on the electronegativity difference, it will fall under the category of either ionic, polar covalent, or covalent or non-polar covalent. So what do I mean by this? So let me give you an example here, and then that will be it for today. Okay, and let me see, here we go. Come on. There we go. All right, so let's take a look at this one. So let's look at nitrogen and oxygen. Okay, so you might say, what's this change in En? Well, if we look on page 333, we see that nitrogen is 3.0, oxygen is 3.5. So here, in this case, if we look at the difference, so nitrogen is 3.0 and oxygen is 3.5. The difference, the difference here is, let me just write this, 3.0 minus 3.5. The answer is 0.5. Now, you might say, Mr. Chan, does it matter if it's 3.0 minus 3.5 as you wrote, or 3.5 minus 0? The answer is no. What you're doing is you're looking for the absolute value. So in this case, where does 0.5 fall? It falls in, if you take a look on page 334, 0.5 falls in this particular range. So 0.5, okay? So the type of bond is polar covalent. So I'll call it polar C, polar covalent. And the atom would be with a greater electron share, in this case, would be oxygen, oxygen. Now, why would it be oxygen? Is because of the fact that when you take a look, oxygen has a greater electronegativity, okay, compared to nitrogen. And as a result, it will, in the sort of electron tug of war, it will get the electrons more, okay? So that's the introduction to bonding. And what I will do is I will be giving you the homework for this particular section for you to be aware of. All right, ladies and gentlemen, thank you. Have a good day. Okay, so bye-bye.